Здравствуйте, это тестовая запись. Can you see the window? Hey guys, I don't hear you guys. Okay, maybe my recorder mutes my microphone. Okay, so let me continue. You just write to the okay. So here we open our project. We see modules inside it. So the core module is the parent of all core modules inside of it. So let's again go through Agent Manager. Agent Manager is a simple module which is a registry of connected agents. It has only these methods: get agents, get physical agents, get LXC agents, get agent by hostname, get agent by UID, get LXC agent by parent hostname. So these methods all operate on currently connected agents only. So if there are no agents, then they will return nothing. These agents will return null, these methods will return null, and these methods will return empty sets. So if there are connected agents, so accordingly they will return, this method will return all agents, this will return physical agents, and so on. Also, this module enables you to subscribe to agent events. A listener can be notified, and the listener must implement this interface, and it will be notified if anything changes in the collection of currently connected agents. So if agents connected, new agents connected or disconnected, this method will be called on all listeners and supplying the set of all currently connected agents, fresh agents. So this is all about this bundle. So this bundle uses, and all other bundles communicating with agents uses Communication Manager. Communication Manager is a simple bundle which allows you to send a raw request or to agent or broadcast request to all agents. Or you can also subscribe to events. Listener must implement response listener interface, and it will be notified on any response coming from agent. So this bundle is a bridge between broker and all other bundles which use them. So the most important bundle which you should all know is a command runner. Command runner allows you to send commands to agents, to connected agents. So command runner allows you to send the following command using following methods. You can send a command asynchronously or synchronously. If there is a suffix async, then it means it's run asynchronously to the calling party. If it is without async, then it is run synchronously. So what it means to synchronously or asynchronously? So when you call run command, synchronous version, then this call will return only when the command is complete. That means that agent send execute response done or execute timeout response. Otherwise, if agent sends just intermediate responses like execute response chunks, then this call will not return and wait. Also, this call has implicit timeout. Implicit timeout currently is 24 hours. So that means if a final message like execute response done or execute timeout hasn't appeared within 24 hours, this command will time out. This call will return and the command will be like expired. There is also explicit timeout, which is set by client. This explicit timeout in a command Let's investigate the command object. So when you use request builder, you call its methods to create a request. So you supply here in the constructor, you supply the command itself. For example, ls command. Then by using additional methods, you can supply additional parameters. For example, you can supply current working directory, or request type, or standard output redirection, or error redirection. Or you can supply also timeout, explicit timeout to agent. This timeout is used by agent. Yeah. Okay. Yeah. What's up? Mm-hmm. Okay. So we came from. So in order to use command runner, we need to know how request builder works. So request builder is a utility class which enables you to create a request. Request is a command which will be sent to agent. So the request builder has a constructor. Here you supply a command. The command is a Unix command like ls, pwd, or some other command. So by default, other parameters have default values. For example, timeout has 30-second default value. Request type is always execute request. Standard output redirection is always return, and error redirection always return. And root user is always root. So and no command line arguments or environment variables are set by default. So you can set them using additional calls like with cvd, it means current working directory, with type, request type, and other parameters can be set. So here is an example. Let me share another screen with you. Let me share with you this screen. Yeah. So this is a command runner model, the most important module which runs commands to agents. So command runner model uses agent manager and communication manager on a low level to send commands via ActiveMQ. So here I described the API exposed by this module, which you can also look. It has commands, Java docs. So it has basically it has two modes of sending commands. One is asynchronously and one is synchronously. So the difference between them is that when you run a command synchronously, it will return only after the final response from agent arrives, like execute response done or execute timeout. So here is an example how to set the command. For example, command runner create broadcast command. This is an example how to create a broadcast command. The broadcast command is sent to all currently connected agents at the same time. For example, we can send apt-get update command and set its timeout to 90 seconds. So here we create a request builder and supply this request builder to create broadcast command method. Then we get command in result, which can be used to send it. Here we send it asynchronously. So this means that the command will be sent and the call will return immediately without waiting the completion of command. If you want to send synchronously, here is another example. For example, command runner also has overloaded methods of create command. First parameter is a command description. For example, start routers for MongoDB. Here you supply a request builder instance and you are building a command. For example, Mongo and some switches. And you supply arguments to this command. And then you set timeout to some value. And the last parameter is the agents, the target agents, which will receive the command. So here we supply a set of commands. Here you can see this call. Create command, description, request builder, and set of agents, target agents. So then you can send this command using command runner run command method, and you can also register a callback. The callback is used when you want to be notified on responses. Every time a response arrives from agent, this callback is triggered. So you have here the original response, which comes from agent, the cumulated response, which will contain all the chunks tied together. They will cumulated together in one response, and the command itself. So here you can check agent results, get std out, which returns standard output, and you can check its contents. So this is why the command callback. This is how command callback can be used. Otherwise, if you don't need to process the response, you can just run command without callback, like this, and it will return when the all commands completed. It means that all agents send final response, like execute timeout or execute response down. So here in the callback, we can also inside callback we can also call a stop method. What it does is that, for example, sometimes there is a long-running command which sends output to Subutai but does not complete. If we can check output using this agent result get std out method, and if we have enough information and we don't need to wait further any longer, we can call stop here, and this call will return after we are sure that the command did what it's supposed to do. So the stop method is just convenience utility. So here I put the description of all the parameters and nuances of these calls. Also, as I mentioned before, we have two types of timeouts. One is explicit timeout, which is set using request builders with timeout method. This explicit timeout is used by agent. If command does not complete within this timeout, the agent kills fork process, and command status will be command status failed, and agent sends execute timeout response. If this command completes within 30 seconds, then command status will be succeeded, and agent will not kill the fork process. The fork process will complete itself. So another timeout is implicit timeout. Implicit timeout is a constant value of 24 hours. It is actual when no response from agent comes within 24 hours for the command. So no response at all. If no response at all arrives, then this timeout occurs, and the Subutai itself return this call. This call is returned, and command status will be command status timeout, and it will be considered as this command is failed. So the command has two convenience methods: has succeeded and has completed. I don't know here has completed. So if execute response done appeared or execute timeout appeared, the command status will be has completed. If the execute response appeared and exit code is 0, then command has succeeded will return true. So the agent result, which here you can see in here, yeah, this one. Here you can see its methods. It provides you with get exit code, get standard out error output, and UID of agent. Also, request builder I described here. Its convenience methods for setting command parameters, request parameters. Also, there is one special thing to notice that, for example, this command in this call, when we create command like this, it will contain the same command string, and the same command string will be sent to all these three agents. So these three agents will be sent the same string. But there are some use cases when we want to send different commands to different agents. So here we use this agent request builder. So agent request builder in its constructor accepts agent, the target agent, and command. So this agent will be sent this command. So for each agent we can specify different command, and we can accumulate all these agents in one set and send the command, create command, and send it to all agents at the same time, but each agent will receive its own specific command. Okay. Okay, let me share with you again my idea screen. Okay. So now we finished with command runner module. So now we go to DB Manager module. DB Manager module is just a simple module which allows you to store or retrieve information from database. So usually we should execute, as you see there are a lot of deprecated methods, and for now the actual methods are just these two ones: execute query and execute update. These two methods, they receive string, SQL string. It's kind of SQL, but Cassandra query language. Insert, update, delete, select, and some like bind parameters. If you don't have any bind parameters, you don't supply anything. If you have, you supply here. This is just a var arg, and you have two methods. Execute queries for selecting something from database, and it returns result set, which is similar to like standard GDBC result sets of other databases. And execute update is meant to be used for delete, like update, truncate kind of operations. So that's a very simple module. To use it properly, we have to create a new table in a Cassandra key space if we need it. For the current modules for plugins, we have already created necessary tables, and I will show you later when we are using in plugins. We are using plugin common, one class here, plugin DAO. Plugin DAO allows you to save, get or delete information from the database concerning plugin information, like cluster configurations. So this is used mostly for these purposes. So let's continue. Okay, we have now another very important module is LXC Manager module. LXC Manager module allows you to create containers from templates, also to destroy containers from templates. So it has the following methods like clone. Here we can supply template name out of which to create containers, number of nodes to create, agent hosts. This is a collection of physical agents on which to create the nodes, and placement strategy. So it's a LXC node placement strategy. We can use round robin or other strategies. So when you call this, it returns you after some time. It returns or raises exception. If exception is thrown, then it means something wrong happened. If it returns successfully, it will return a set of agents. This is a set of created agents, physical LXC agents. So these agents will be placed on these physical nodes. Also, we can by one we can create a container using the host name of physical server and host name of the target container to be created. We can destroy it or we can create it. So here this method clones create enables you to create on this physical machine from this template these containers. Here you supply host names of containers to be created. For example, you can create on physical one out of master node. You can create LXC1, LXC2, LXC3. All containers, if everything went well, their agents will connect after some time to Subutai, and you can use agent manager to query these agents to see if they are connected. You can supply here the host name of container, and if it doesn't return null but returns an agent instance, then it means the agent connected successfully. So that's very simple. So we have here also LXC manager package, which handles old style LXC container creation. It contains LXC creation using LXC clone, LXC destroy, LXC start methods. This one uses Subutai clone, Subutai destroy methods. So this one will eventually go away, and we will keep just this one, container manager. So also what you need to know, the other core modules are just utility methods for the main methods or for plugins. For example, we have also one important module is template registry. Template registry is a module which stores, which allows you to manage template metadata, which is stored in Cassandra. For example, it exposes the following methods: register template. So to register a template, template manager exposes a REST API, which allows you to upload. I think here you upload a template, and it will upload it to Subutai server, and in turn it will call this method register. It will supply configuration file, packages file, and MD5 sum. It will extract the template contents, and it will extract the configuration file, packages file, figure out the MD5 sum, and register this template in a registry. So what it does, it just persists the information about template in the Cassandra. The template itself is located in apt repo, and in Cassandra we store only its metadata. So also we have unregistered template call, and several calls in template registry manager throw registry exception. So it can be thrown in such cases when you try to register a template with which has the same name as already registered template, or the same MD5 sum as already registered method, or it does or several other cases. Also, unregistered template will throw exception if you are trying to unregister missing template or template which has children templates, or a template which is used currently on some of physical servers. Also, template registry provides you utility methods for querying template by name or by name and LXC architecture. LXC architecture, if it's not supplied, the default LXC architecture used is AMD 64. So this is the same as calling this one and supplying here LXC, AMD 64 LXC architecture. And all the other methods which have duplicate overloaded methods like with and without LXC architecture work the same way. If you don't supply, then AMD 64 is considered. So you can get child templates of parent template, you get parent template of child template, and you can get all templates in the form of tree or just a list of all templates without any hierarchy. And some other methods used by scripts, Subutai scripts, like this method is used by Subutai scripts when a template is registered somewhere, so that Subutai knows that it is used on some FAI. Here the FAI physical hostname is supplied, template name, and if it's true, then it means it's used, and if it's false, it means that it's destroyed or unregistered. And this method allows you to query this information provided by the previous method. If it returns true, then it means that this template is in use on some of FAIs. If it returns false, that it means it's not in use on any of FAIs. So this is template registry manager. Now we have template manager. This is just a wrapper around all Subutai CLI scripts. What it does, it just wraps all Subutai commands like Subutai clone, Subutai destroy, and exposes them through convenient API. So when you call, for example, template manager clone, it in turn calls Subutai clone on this physical host name using this template name and this clone name. And the same applies to all these methods beneath. For example, when you call promote clone on this host name and this clone, it calls Subutai promote on this physical machine. And the same applies to all the methods here. And you can see the Java docs are also present, so you can check them later. So let's go further. Now we have tracker. Okay, tracker will wait. Tracker is used mainly by plugins for logging information and viewing information in UI. So what we missed here? Okay, for example, we have Git manager. Git manager is used mainly by Subutai itself in registry UI. So registry UI will allow you to see the differences between files in templates. For example, if you have master template and Hadoop template, registry UI, which is not implemented now but it should be implemented in the future, will allow you to see the difference between master and Hadoop, exactly, particularly in configuration files. What changed? What changed in configuration files? What packages were added? So for these purposes, this module is internally used by Subutai, and it exposes Git specific commands like div branches, div file, git init, git add all, git commit, git checkout, clone, merge, list branches, push, stash, and these commands are Git specific commands, and this module is internally used by Subutai, and it's not for usual usage by other plugin add-ons. So okay, there are two modules which are connected to each other: configuration point tracker and file tracker. So file tracker is a module which allows to set for agent to send a command to agent which sets tracking of specific configuration points. For example, we can send to this agent we can instruct this agent to track these configuration points. The configuration points is just file paths. For example, some var slash Hadoop slash something. Yeah, we can call this method, and this agent will be tracking this path or a set of paths. So this module is used internally by configuration point tracker, which is in turn must be used by clients. Configuration point tracker is not fully implemented at the moment.